All right, welcome to 7.6, our last set of notes for this unit. You are going to have a review on Tuesday. We do test Wednesday, Thursday. This is the last little bit of information. All right, one thing you're going to need, graphing calculator. Makes it a lot easier to do this, okay? The other thing is we gotta think back to some of the things we've done before, all right? One of the good things to do this, if we're going to do this by hand, is you want to think input, output. Input, output. The other thing that we need to think of is what happens when a radical becomes negative inside. If I have a radical, and if I have a negative, and I'm just going to say negative x, what happens? Well, remember, it becomes irrational, right? And it ends up being an I out front of that to be able to pull that negative out. So we can't have negatives underneath the radical. That's the first thing to remember. So as I go through these, just keep in mind that I can never have a negative number underneath. It's not real. That's imaginary, correct? And so if it's irrational imaginary, then we can't do it. So everything has to be positive underneath the radical, okay? So as we look at this one, the parent square root function. So what we're doing today is we're graphing square root functions, okay? That's what we're doing. If I look at this, and I've thought about input output, if I have a radical x, well, if I know that this can never be negative, then where can I start? Well, I can start at what value? Well, I can start at 0. What is the square root of 0? 0, right? And we can find that in the calculator. And for every value up above that, there is going to be something else. So if we put 1 in, 2 in, 3 in, 4, well, we know what the square root of 4 is. It's 2, right? So everything here is going to be a decimal going up to this. But as you can see, it's going to go up this direction, okay? That's how I would do it by hand. Reality is, we could take this, and remember, hit y equals, put in the square root of x, and we know how to do that. Hit enter, hit graph, and you're going to see the same thing that's up on the screen right now. And remember, if I want to look at the table, I'm just going to hit second in graph, and that's going to give me my table of values as I go through. Okay? And I'll try to get it up there so you can see that table. There you go. So notice that we can do this by hand and we can do it by calculator. Well, obviously the calculator is going to be the easiest, right? All right. So this is what we're working on today. The next thing, vertical translation of a square root function, basically means that if I have a value outside the radical, so if I had f of x, and remember f of x equals to y, right? So if we're thinking about input, output, f of x is the same thing as y equals. So as I do this, if I had f of x is equal to the square root of, let's say, 4, and I said plus 2. Well, I know that the square root of 4 is 2, but if I add 2, then f of x, well, f of 4, because I plugged a 4 in there, right, is going to be 4, which means that when x is 4, it's going to be up there, right? Now, as I do this, if I say square root of x plus c, if it started at 0, right, if I started when when x is 0, if I did this, well, what is the square root of 0? Well, it's 0, right? 0 plus 2. What it's saying is that in my graph, if I plug a 0 in for this x right up here, that I'm going to start 2 places up. Well, that should make sense because I have an add-on of 2. That is what vertical translation is doing. It's moving it, it's shifting it up, it's translating it up 2 spots. All right. If I was going down by -1, I'm going to slide down, so I'm translating down. All right? So whatever's outside shifts the graph up and down. Notice, remember, our just square root of x starts at 0, goes up like this. Once I start adding or subtracting from outside the radical, it's going to shift the graph up or down, right? And then let's talk about one more shift. If I add or subtract underneath, it's also going to shift it one direction or the other. It's going to shift it left or right, depending on if I plus or minus after the x. Easiest way to find this of where it's going to start is take what's inside, which this is the square root of x minus a inside, take that and set it equal to 0. So if I added a to both sides, x is going to be equal to a. Well, that's where it shifted either left or right. In this case, it shifted it to the right because it's positive, right? It's positive. All right, so does that make sense? So if I'm going to have a vertex of this graph be away from the origin, either to the left or to the right, it's going to be from the terms underneath the radical sign. All right, so let's see that. Now, domain of a square root function. Well, domain refers to what values? Well, the x values of a graph, correct? So the x values. So the domain of a square root function is restricted to the numbers that make the value under the radical sign greater than or equal to 0. So it's kind of going back and saying exactly what I just said right at the beginning, and that is I can't have a negative underneath the radical sign. It's imaginary. It's irrational. I can't do it. So to find the domain, which means my x values of the graph, the domain, the x values, my input values, right, of this graph or of this function, then I take what's underneath and I set it equal to 0, because remember it needs to be greater than or equal to what's underneath 0. All right, so I look at this. The easiest way to do this is just take the terms, set them equal to 0, solve for x. Perfect. So x is equal to -4, which means every term equal to -4 or greater than -4 is going to allow me to have this be a true function, okay? So what would I say? Well, my domain for this is going to be x is greater than or equal to -4. All right, let's do the next one. Underneath the radical sign is 3 times x minus 2. Well, if I look at this, take what's underneath the radical, set it equal to 0. That's my starting point, right? It's my starting point of this graph. So I look at this. 3 times, well, I got to distribute, right? 3 with the x, 3 with the -2, so 3 times x is 3x. 3 times -2 is -6, equal to 0. Add 6 to both sides, so 3x is equal to 6. When I add to both sides, divide by 3, and x is going to be equal to 2. So what that is saying is that my domain has to be equal to 2, but I also know it's going to be greater than 2 as well. So x is greater than or equal to the value of 2. All right, let's actually graph one. Now I'm going to do it old school. I'm not going to do it via the calculator. I could. I'm going to grab my calculator right now. And here we go. The first thing I can notice is that my vertical translation, remember this term right here is going to be my vertical translation, right? And that means that my graph's going to start up or down, whatever it is. Well, in this case, it's down. It's going to be down 1. So I know that I'm going to start down here. My graph is going to start on this -1 for the y equals -1. Okay, I know that, but I want to find my starting point of the graph. Well, if I look at this, x plus 2 underneath. So if I start and I go x plus 2 is equal to 0 because I want to find my domain, right? My domain. I subtract 2 to both sides, then x is equal to negative 2. So I know my good starting point is going to be negative 2 on the x values. So I look at this, and let's do an input-output table. X, y. This is my starting point. It can't be anything less than that. So negative 1, 0, 1, and 2. Nice, neat numbers, easy to do, all that. So I look at this, and let's go ahead and plug negative 2 in for x. So I'm going to do it right here, and I'll do it in green. So I have y is equal to 2 times the square root of, I'm going to start with negative 2 plus 2 minus 1. Well, y is equal to 2 times the square root of 0 minus 1. Well, what's the square root of 0? 0. What is 0 times 2? 0. So this is going to be y is equal to negative 1. So I have the value of negative 1. Now, we would do that for every value. Negative 1, 0, 1, and 2. I have done that already. I'm just going to write them down. And that gets me where I need to be right there. All right? So I've already done that, and I plugged them in. All that's ready to go. So now, from here, graph it. My starting point's in a negative 2, 1. Negative 2, negative 1. Well, I'd already known that my vertical translation was going to be a negative 1. So there it is. I proved it. It's there. Now notice that we started with positive 2 underneath here, and we got to negative 2. Well, it is slid over 2, right, to the left-hand side. So that is still accurate, right? Negative 1, 1, negative 1, 1, 0, 1.82, right around there. 1 is 2.46, somewhere in there. And 2 is 3. There. Draw your line, and away you go. There's our graph. All right, you have several of these to do. You can do them in the calculator. That is fine. It works. Or you can make an old school table. That works as well. Have fun. Please behave. I will see you on Tuesday most likely. Thank you. Have a great day.